Hey everyone, I'm Anish and welcome back to PrepFusion. So today we'll be starting the lecture 3 of frequency response of polar plot, right? So like in the previous lecture, what we learned? We basically learned how to plot the polar plot, what are the x and y axes basically, and what are my x and y points, right? And we learned a bit of about angles. Also we learned a bit about the head and tail of a polar plot, right? Also the relation between type and order, right? So like type, I told you like there are a few conditions that the angle should be between 0 to 360, right? Then only that is valid. Like here, right? If this angle is like between 0 to 360, then it is valid. Then only I can discuss about the type, right? Else it will become a cycle, right? Repetitive cycle. For type 5, how will I say? For type 5, what will be the initial angle? I can say it as like 5 times 90, that is 450 also, or I can say it as 90 itself also, right? Sorry, minus 450 or minus 90 also, because I'm simply just adding plus 360. So it will not be unique. So I'm restricting my angle to 0 to 360, right? So yeah, I hope you got that point. This is not that important, right? This is not that important. Just few key points. Few students like to write all these things and yeah, short tricks. These are not that important because you can anyways find the type. It will just take you 1 second or 2 seconds. Okay. So yeah, that is one thing. Okay. So we learned how to plot the polar plot, right? And like the equation of circle, I haven't done that yet. Okay, so that is for you homework, that you use the method 1 and plot here, right? And see whether it will come as circle or whether it will come like this one. That is for you. Okay, so yeah, that is it for that lecture 2. Now let's start the lecture 3. So in lecture 3 mainly we'll solve questions, right? Mainly we'll do few more polar plots, right? So we have to draw the polar plot for the following OLTFs. These were the homeworks from the previous lecture, so we'll solve this now here, right? So the first, what is the first OLTF? First OLTF is this one, right? Oh no, I did it. Simply again for simplicity, I will make like later stage tau 1 equals tau 2, but now for now I'm not doing it. So again we'll use the second method basically. What we'll do? Simply first find the put s equals to j omega. That will be my frequency response. So s equals to h of g omega, which is 1 by g omega 1 plus g omega tau 1 into 1 plus g omega tau 2. Okay, so now what is the magnitude of this one, right? So what is the magnitude? Magnitude was simply this will come out to be only omega, right? Okay, this is only omega. So yeah, this is this one. Now let's find the angle of this one. What will the angle? So I'm just doing it directly now. I'm not explaining anything because all this we have done this multiple times, so that will just waste our time, right? G of g omega, h of g omega. Okay, so we do this one. Now what is the angle? Angle basically this one will contribute how much? 90, but it is in the denominator, so it is minus 90, right? And all of this will also contribute minus, but there is tan inverse omega tau 1 and there is tan inverse omega tau 2, right? So minus 90 tau 1 minus tan inverse omega tau 2, right? So yeah, these are these things. So this is my angle, this is my phase. So let's again use the table, right? Always use the table. Okay, so for what critical values I will plot, right? I will find the values. One is 0, another is 1 by tau. So what I will do is make tau 1 for easier calculation. I will make tau 1 equals tau 2, right? Okay, like don't worry, like this plotting stuff, right, may not come in exam, but a few things related to this plotting stuff, what procedure we're following, may be handy in your exam, right? So it's important that you follow along, right? Obviously you don't need to exactly plot everything, right? You're doing handwritten calculations over there, which is impossible, right? to plot everything exactly. But this procedure what I am following, it may be useful in some other question, right? So that is very important, right? So yeah, just wait 1 second. Just let me move my camera a bit. Yeah, now it's fine. So yeah, this is 1 by tau. This is infinity, right? 0 infinity. Now like what is my magnitude at omega equals to 0? Okay, I forgot to write here is that tau should be equals to tau 1 equals to tau 2. All of them are equal, right? Okay, all of them are equal. So my tau equals tau 1 equals tau 2, then what is my magnitude basically? So magnitude, right, if I put 0 over here, then this becomes infinity. This blows up, right? Even if I have a type 0 system, or type, if my type isn't 0, then obviously at omega equals 0, I will always have infinite magnitude. Okay, infinite magnitude. So this will be infinity, right? This will be infinity. What about my this one? What about this one, right? So what is 1 by tau? At 1 by tau, what is happening? 1 by tau, like this is equal, right? So this becomes 1 plus 1 2, 1 plus 1 2. So this becomes root 2 times root 2, which is 2 itself, right? Now this is what? This is 1 by tau. So it is again tau by 2. Okay, previously what was it was tau by root 2. Now it is tau by 2. So if you remember from the previous question, right? So this is tau by 2, right? Or 0.5 tau, you can say. Okay, and what is omega equals to infinity? What is omega equals to infinity? Omega equals to infinity is like if you put omega equals to 0, simply you are getting 0, right? We don't have anything here, and this is going to infinity, so simply magnitude is in 0, right? Now what about my angle? What about my angle, right? So angle, right? So if I put omega equals to 0 here, this vanishes, and we're left with only this one, which is minus 90. So my initial angle is minus 90. So it will start off from the imaginary axis, like this one only. I will show you that you will understand. Minus 90. Then at omega equals to tau by 2, right? Sorry, omega equals to 1 by tau. What is happening? So these are equal, right? So this is tan inverse 1. This is tan inverse 1. So it is 45, which is 90, and we are doing minus 90. So minus 90, which is minus 180 basically. So minus 180, right? And then again, what is this one? So this one, right? Like at omega goes to infinity, so this is going to 90 again, this is going to 90 again, right? Tan inverse infinity is 90, 90, 90, and we have another 90, so it is going to minus 270, minus 270, right? So we're going to minus 270. Now like as you can see, I'm starting from 90 and I'm ending to minus 270. What does this represent? So this represent, right, my type is 1, right? As my angle is between 0 to 360. Okay, my type is 1. Okay, initial angle. And what does this represent? This represent that my like order is 3, but obviously if I only have poles, then only this can say about the order, right? If I have also zeros, then I won't be able to comment about the orders, because 0 will also contribute some positive angle. Okay, that's why. So let's plot this now. So initially it is starting from minus 90 to infinity, so it will start something like this one, right? And why am I starting from here and not here? Why? Because it has already crossed 90. Okay, after just this point, it is going to towards minus 180. It is going towards here, so I will start from somewhere here, not here. Okay, because it has already crossed 90 and it is going towards 180. Okay, that's why I'm not starting from here, I'm starting from here. So again, right, it will be similar to like the previous question, right? The start will be similar, right? Start will be similar. This will be okay. I will mark the points later. It will start from somewhere here, and then what is happening? It will go towards minus 180. Go towards minus 180. And what is happening? It is also crossing minus 180, right? At tau 1 by tau, it is crossing minus 180, and then it is going towards minus 270. So the angle is minus 270 basically. Okay. So yeah. So the like first I will draw it, then I will explain it further. This is difficult. Okay, so what is this angle? this angle is 270 basically. This angle is 270, right? And like I will understand it's ending towards 270, right? So it is starting from here. It is going towards here, right? And this is omega equals to infinity. And this is omega equals to 0, right? This is omega equals to 0. Okay. So it is going like this one, and like this, like the point at which it is cutting the negative real axis, right? The distance from the origin is tau by 2, right? That is the magnitude, right? So the distance from the origin is tau by 2. Okay, so this is 0.5 tau, right? So yeah, this is basically the plot. I hope you understand that this is again, right, this is not 0-degree angle. Okay, the ending is not 0 degree. It is just measure the angle from positive real axis, right? It is 270. Don't forget that, right? So yeah, the plot will something look like this. Okay, the magnitude, what you can see, is reducing. So here, right, the magnitude was very high, then it is reducing, then it is reducing. So here, right, like it is looking like it is increasing, but it is actually reducing. Okay, but like, okay, that is my fault, so I should have started it. That is fine. So just assume that this is reducing, right? So that is important. So the structure is not important because this is just an approximate plot. Okay, so yeah, I think that is it for this question. The plot is done. Okay, nothing much to like focus on all. So I'm just plotting you a few standard OLTFs, right? So with the help of this you can solve many questions. So I'm plotting the standard OLTFs so that this comes into your mind that yeah, this OLTF will look something like this, this OLTF will look something like this. Okay, so that you get accustomed to it, right? So yeah, now let's go for the sixth question. So this is my sixth question basically. So this is my sixth question, right? So again, right, I will follow the same procedure, nothing different, nothing fancy. So I simply copy this one, right? You see how fast this is. Like the imaginary part, what you have to do here, right? You have to firstly do the complex conjugate. That is very difficult. As the order increases, to do, like, you have different factors, you have to multiply this, then you do the complex conjugate. That will be very time consuming for you, right? So this one is much easier, right, as they are in factorized format, and you can simply find the angle and the magnitude with less amount of time, right? Less amount of time will get consumed. Obviously for the gate you have to follow this rule. You won't be able to follow that rule for higher order systems, right? So yeah, that is the reason. So here, right, I have another pole that is at 1 plus j omega. So what I am doing, I'm just simply copy pasting, but I hope you understand, right? I'm putting s equals to j omega here, and I'm replacing s equal to j omega. Then obviously I'm finding the magnitude. So this magnitude part is same, only this one is extra added. Okay, so this only extra magnitude term omega tau 3 will get added. So yeah, this is the magnitude basically. Okay, so now what is the angle? So angle, again I will copy paste. Okay, just one extra term will get added, that is the minus tan inverse omega tau 3. I hope you are understanding, right? So what is happening, just one extra term, right? This extra term minus tan inverse omega tau 3 is getting added. Okay, so yeah, this is getting added, right? So yeah, this is basically the angle formula. So what will happen this time? The difference will be, the type is still same, one pole has been added, right? So what will happen, the head will change but the tail will remain same. But here, right, angle is between 0 to 360. After this order 4, right, then things will be a bit difficult to just tell by head and tail, right? Okay, that is difficult. Okay, so that's why I told you the angle should be between 0 to 360. So let's again do the critical points, right? Omega 0, again 1 by tau, and this infinity, right? And my tau is tau 1, tau 2. So what is again the magnitude, right? Magnitude at 0, again, right, it is blowing up, it is infinity, because I have a j omega term here, right? So even these are finite, but this is 0, hence we're going to infinity, right? 1 by 0 is infinity. So this is going to infinity, that is not an issue. 1 by tau, what is happening this time, right? It will be a bit different. Okay, what will happen? Let me write this properly. So basically, right, this 1 by tau, 1 by tau basically, okay, sorry, not here. If I put 1 by tau over here, right, what do we get? This is 1 plus 1 root 2, this is 1 plus 1 root 2, this is 1 plus 1 root 2. So I'm getting 2 root 2, right? And this is 1 by tau, so this is tau by 2 root 2. Okay, tau by 2 root 2. I'm not calculating the exact value, that's up to you guys. Okay, I think it's like 0.707, right? 1 by root 2 is 0.707. Now you divide it by 2, what do you get? You get like something 0.35 35, right? 0.3535. So it is something like this one. Tau, right? Okay, I'm just approximating it is 0.35 tau, right? So yeah, this is this one. Now let's find the infinite impedance, like, sorry, the magnitude at infinity frequency. So at infinite frequency, obviously this will go to 0, because in the denominator we have 0 and in the numerator we have a finite value. So this will go to 0 basically, right? So if this is going to 0, so this is going to 0, right? Now what is the angle basically? What is the angle, right? The angle, right, what you can see is at 0 again, right, we'll be only left with minus 90. And what is like at 1 by tau? What is at 1 by tau? It is 45, it is 45, it is 45. So it is minus 135, it is 135, and it is minus 1. Okay, well, just wait a second, I have a call actually. Yeah, sorry for the interruption, like someone came at the door, so I had to again like restart everything. So as I was telling, right, this will be simply a tan inverse omega tau 3. Just one extra term will get added here, right? So next what will happen again, right? I was drawing the table. So at like this 1 by tau, what is happening? Like this will become 45, 45, 45, and overall it is minus 135. So minus 135 and minus 90 also I have. So what do I get? I get minus 225, right? Minus 225. Okay, I get minus 225, right? And like at omega goes to infinity, what do I get? Omega goes to infinity, like this becomes like tan inverse infinity is what? It is 90, 90, 90. So minus 270 minus 90, so it is minus 360, or you can say it as 0 degrees, right? You can say also 0 degrees, like 0 degrees or minus 360 plus 360, whatever you want to call, right? Anything, right? So yeah, now let's basically plot this one, right? So what is happening initially, right? The starting point is same, right? What I'm trying to explain, the relation that I told, right, about type and order. So as we have only one type 1 system, so the starting point, the tail is same, right? Tail is same, starting on the same point, but the ending point or the head is different every time, right? Here, like at the starting, it was something like this, then I had something like this, then I had something like this. Now this will be something like this. Why? Because what will be the angle between this positive x-axis and my polar plot at omega goes to infinity? It will be 0, right? It will be 0. So what will happen again, right? Let me draw it first. So it will start somewhere from here, right? Start somewhere from here, and then it will go something like this, then it will keep on reducing, and like this, right? So it will go something like this. Obviously this is not perfect, I will try to make this more better, right? But obviously this is not perfect, right? Okay, so this will go on like this. Okay, so this is basically tau by 2, right? This is basically tau by 2. So yeah, this is tau by 2, and like here, right, what you can see, the head represents the like the order and the tail represents the type. But here we have the perfect OLTIF like that. If the OLTIF is in the form like that, then obviously we can understand the head and tail from there, right? Else we can't, right? So yeah, this is not tau by 2, this is tau by root 2 basically. Okay, let me write this in different. Okay, this is tau by root 2, and like this is the tail, you can see, and this is the head. So this is at omega equals to 0. Okay, this is at omega equals to 0. and this is at omega equals to infinity. As you can see, right, the angle is 0 with respect to this time. The angle is 0. Okay, this time the angle is 0. Why? If we try to measure the angle from this positive x-axis, right, we're getting 0. So that's why the angle is 0 this time, right? So yeah, that is it for this plot. So what I have done, like we have also few more questions, right? This time, right, I'm taking the values this time. Okay, instead of like just taking some unknowns, right, this time I'm taking some values. Okay, so let's start with some values. Just let me wait, check if it is recording. Yeah, it is recording, that is fine. So sometimes I have to check, right, if it is not recording, then it will be, I will just mad. Okay, so now, right, basically we'll draw the polar forward these two. So you try to do it by yourself. Okay, we know the shape already, right? We already know the shape. Okay, you try to do it, solve it by yourself, right? So again, right, I will try to copy this one. Okay, and try to plot this one. Like again, right, everything will be same like this one here, right? I will just simply copy and paste. Everything will be same like this one, except, right, I don't have a type 1 system this time. I have a type 0 and order is still 4, right? Order is still 4. So I'll just copy this one. Okay, but I have to make few changes. So I, okay, did it got pasted or not? Okay, yeah. So what will happen, right, here, right, I have g omega plus 1. So I will replace this one with g omega plus 1. Okay, g omega plus 1, and this one will be, okay, all of this one, right, all of, okay, let me, this one will be g omega plus 2. Okay, g omega plus 2, this one will be g omega plus 3, and this one will be g omega plus 4. Okay, so yeah, this is this one, right? So yeah, these are like frequency response. Now what is the magnitude basically? So I have to rewrite this again, so it's just a waste of copy pasting, sorry for that. So like what will be the magnitude? I'm not able to find. So basically, right, this will be under root omega square plus 1, this will be under root omega square plus 4, this will be under root omega square plus 9, this will be under root omega square plus 16 basically, right? So all of this one magnitude is this one. Also, like I forgot to write the numerator this time, right? We don't have 1 anymore, we have 48, right? 48 in the numerator basically. So yeah, we have 48. Now what is the angle basically? So the angle, right, if you copy the angle, so I won't copy the angle anymore, I will just write this directly, g of j omega h of j omega. Okay, what is the angle this time? The angle, right, angle this time we don't have like numerator, we have 0, right? It is 48 only, and angle of 48 with respect to positive real axis is 0 itself. And now it is the angle contribution due to this poles, right? It is basically, first one is tan inverse omega, next one is tan inverse, I have the negative sign at the outside, right, tan inverse omega by 2, and next one is tan inverse omega by 3, and next one is omega by 4. Okay, so yeah, these are this one. Okay, so yeah, the angle contribution is like this one. Now let's go for the plot, right? Let's go for the plot. So if I just take 2 points, right, if I just take 2 points, what will happen? So simply if I take like omega equals to 0 and omega equals to infinity, what is happening? At omega equals to 0, what is my angle? Okay, let's first do the magnitude. At omega equals to 0, what is my magnitude? Magnitude is So if I put 0 over here, right, so what does this become? This is 1 times 2, under 4 is 2, times 3 times 4. So 2 times 3, 6 times 4, 24, 24, 48 by 24, it is 48. So it is 48, right? And what is, like, at infinity, what is the magnitude? It is 0 itself, right? It is, sorry, not 40, sorry, it is 2. 48 by 24, it is 2, right? And at infinity it is 0, right? So this is going infinite, so this is going to 0. Okay, so this is fine. Now what is happening? What is my angle at omega equals to 0? So at omega equals to 0, what do you get? This is 0, this is 0, this is 0, this is 0. So tan inverse 0 is 0 itself. So this is 0 degree angles, right? But omega equals to infinity, what is happening? This is contributing 90, 90, 90, 90. Again, right? 90 times 4, which is 360. So it is rotating a full circle, right? Rotating a full circle and getting back to 90 itself. So sorry, I should write this one as all negative, but that is fine. This at outside it is negative, so that is understood basically. So again, right, it is finishing into 360, or you can say 0 degrees, right? Minus 360 or 0. Okay, minus 360 is same as 360 as 0. Everything is same, right? So yeah. This is this one. Now basically, right, what we need to do is understand that how will the plot look like. What will happen is, it will start, like, the magnitude is reducing, that we can understand, and also it will start from 0 real axis, right? Positive real axis at 2, okay, value 2, then it will keep on reducing, right? So here, right, if you use the method 1, will be very hectic. To use the method 1, you have to rationalize, right? You have to separate the imaginary and real terms, which is very difficult and tedious task to do, right? That's why we use this method. Okay, obviously this is like not that intuitive method to plot it, right? That one, if you just separate the imaginary real parts, you can see directly how will my plot look like. But here it is very difficult, but I can understand that my angle is going in the negative, in the clockwise direction, it is reducing, and my magnitude is also reducing, right? So it will follow something like this. Let me draw it, and then you will understand. So, like, I'll start from 2, right? 2. Then what is happening? My angle is reducing, so it is going in the clockwise direction, and my magnitude is also reducing. So it will go something, okay, like this, right? Go something like this. Okay, not okay. This whole thing gone off. That is bad. Okay. This is 2, right? This is 2, and this is omega equals to 2, omega 0, right? And like, what is this one? This is at omega equals to infinity, right? My angle is going to 0. Here the angle is going to 0, right? So this is going to infinity. Obviously this plot is not that accurate, that I can assure you, but like, get the brief idea, right? What is happening? It is crossing all the angles, right? To rotating total 360, then reaching to origin itself, right? And angle is 0. Okay, so this is my polar plot. Basically, I'm not wasting time writing all this. These are already written, right? So I hope you got the brief idea, overview of how to draw the polar plot basically. So there is also like another question, this one, right? This one is same only. This, how will this one come? Okay, I will just show you how will this one come. This one will come same like this one. Okay, so where was that question? Here, this one, right? It will come, yeah, it will come like this. No, not this one. Okay, I haven't done that. Sorry, this is the combination of these two, right? Yeah, this one, yeah, this one. That's why I thought that we have done this one. So it will be simply a combination of these, right? It will be similar to question 3. Okay, just you have to do it by yourself. So I won't solve it. Okay, just I will mark down the points, right? Mark down the points at s equals to 0. Basically at omega equals to 0, what is my imaginary and what is my real part? So let me break it down, right, to imaginary, real, and there we will understand one thing. Okay, so let me do one thing. Let me do that question, and there we will understand it better. So okay, let me first copy this one, right? Else it will take very much high amount of time. This is some other part, I will show you to you later. So this is not question 3, this is question 8 basically, right? Question 8, yeah, question 8. So this was basically S one, like it was 10 by s into s plus 2, right? 10 by s into s plus 2, right? Now if I put s equals to j omega, what do I get? This will be changed j omega plus 2, right? And what is this? Plus 4, right? This is omega square plus 4. Okay, so yeah, now like what is the angle? Let's say this is the magnitude, right? This is the magnitude, and what is the angle? Angle is basically 90, and this will be omega by 2. Okay, real upon imaginary, right? So this will be omega by 2 itself. Okay, so angle will lie between minus 90 to 180. Okay, this is same only, right? But what I will do is I will separate this one out with real and imaginary parts, right? There also will understand few things. Like this is fine. Okay, this is basically if I do 1 by tau, which is okay. I won't now, right? I will change the table this time. Okay, what I will do is change the table. Okay, just a bit. Solve this using method 1, right? Solve this using method 1. Okay, so like I will try to find the real part of, first I will break this down, right? First I will break this down. What I will do, I will do the rationalization, and I will take this j in the numerator, right? If I multiply by j on both numerator and denominator, I will get minus j over here, right? So this will become minus 1 and I will get minus j over here. So my g of j omega, right? And this is j omega plus 2 into, like what I can do is like, okay, I shouldn't write it like this one. I should write 2 plus j omega into 2 minus j omega. Okay, and this is 10 into 2 minus j omega. Also I have minus j at the numerator, right? Don't forget that one. So this one will become j square, so this one will become 10 omega, right? I'm multiplying this one inside, so this minus j into minus j becomes plus j, like okay, this one becomes minus 10 omega. Okay, so like minus into minus becomes plus, and this j times j becomes minus 1, so this is minus 10 omega, and this is minus j 20, right? Divided by this what is this? So this is omega into 4 plus omega square, right? So this is my what do you say, real part, right? So no, this is a denominator basically. So now how can I separate this one? So I can write this one as minus 10 omega divided by omega into 4 plus omega square. Okay, this one will be cancelled, right? Minus j 20 by omega square plus 4, right? So I get this one. So now what is happening, like luckily this omega is get cancelled, that's why I can put omega equals to 0 over here. Okay, that's why I get some value, and here the omega isn't getting cancelled, that's why my imaginary component is going to infinity. Okay, I hope you understand it, why my imaginary component is going to infinity, and I have a particular real part, right? And this is the real part. From here you can understand, right? So this is minus 10 4 plus omega square minus j20 omega, and both are negative, right? Both are negative. Okay, so both of them will lie in the basically what do you say, in third quadrant. Okay, square plus 4. Okay, so now let's write down this point. What is 1 by tau? 1 by tau, let's say like it is simply, if I take the 2 common, right, it is 2 itself. So we will not plot the 1 by tau right now, we just plot omega equals to 0 and infinity, right? So at 0, what is happening? My real part, right? Okay, I haven't written down this as real. This I have to write this down as real. Okay, so what is the real part? Real part, right? At omega equals 0, if I put omega equals 0 here, no issues, right? It is minus 10 by 4, which is minus 2.5, right? Minus 2.5. So I am getting a finite real part, right? And what is the imaginary part? Imaginary part, right? If you put omega equals 0 over here, like this is okay, this is 4, 20, so this is 5 by 4, that is fine, but this is here also I have a 0, so this is going to minus infinity basically. So imaginary part is going to minus infinity. Okay, now what about infinity? Infinity, both of them are going to 0, right? No issues with that. Both of them are going to infinity itself. So both of them are going to 0 itself. So we are meeting at the origin. Okay, meeting at the origin. But from here, right, we can't like predict the angle basically. Okay, we can predict the angle. So like the angle you have to predict from that one only, like that previous case that we did, right? But what one thing you can understand from here, right, the angle will lie between minus 90 to 180. So from here you can't say about the angle at omega equals to infinity, right? That is one issue. Okay, but yeah, that is a difficult part. So like how will the graph look like? Graph will look like this one only, right? Okay, graph will look like this one only. Okay, and what is this real part basically? Okay, what is this real part? This asymptote real part, right? What is the magnitude of this one? Okay, like the real part of this one is 2.5 only. Okay, minus 2.5 only, but the imaginary part is going to infinity. That's why the overall magnitude is going to infinity itself, right? So I got the point, like why it is not starting from this imaginary axis and why it is starting from here somewhere on the left hand side, right? I hope you cleared that why it is starting somewhere on the left hand side due to this part, right? Due to we have some finite real component, right? Imaginary component is infinite, but real component is still present there, some finite. So like why is it basically, right? If the imaginary component is infinite but real component is finite, then obviously we'll get some value like this one. It will be away from this imaginary axis, right? If my real component was 0, then we would have started from here itself. Okay, so yeah, my angle is minus 90, that is fine, but I have some real component, that's why I'm starting from here. Okay, that's why like the graph plot looks something like this. So I took this example just to show you how my plot will look like, right? So yeah, this one is basically it. Now like basically I have summarized all the polar plots, right, for type 1 up until type 1 to I think type 3, I think. Yeah, type 3. Okay, after type 3 they don't ask, right? So from type 0, how does my polar plot look? How does my polar plot look for type 0 order 2, type 0 order 1, then type 0 order 3, type 0 order 4, then type 1 order 1, all these things, right? I have done it. Okay, so what is your task is to see all these plots and try to solve it for yourself. So few I have already solved them, like most of them I have already solved them, I think, but this one, right, like type 2 order 2, this one I haven't solved, right? Like this one type 2 order 3, this one I haven't solved. So the homework for you is solve this, right? Solve this polar plot and plot it by yourself. So few I have done, few you have to do also, else you will not be able to understand everything, right? So yeah, this is this one. Okay, so okay, so let's go for the next question basically. So in this question, right, what do we observe? We observe one thing, right? We observe the location of the poles, and the location of the pole is at the right hand side of my S plane. So what we call when a system has a location of my pole at the right hand side of my S plane, we call it as non-minimum phase system, right? Non-minimum phase system. We call it as non-minimum phase system. Now if it is a non-minimum phase system, then what will happen basically, right? Then we just have to be a little bit careful, right? Few things will change this time. Okay, few things will change. The angle calculations will be a bit difficult this time. Let's see why. So what is my g of s? H of s is this one. Oh, not delete, just copy. Okay, and like this is simply equals to, if I put g of frequency response, right, g of j omega, h of j omega, what do you get? Okay, so yeah, this is this one. Now right, again we'll do the magnitude and the angle calculation this time. So what will be magnitude? Will the magnitude change this time, right? With normal minimum phase system, will the magnitude be a bit different? Let's see, right? So definitely the magnitude for this g omega will be omega itself, and this is omega square, and this is plus minus 2 whole square, right? Plus minus 2 whole square. How can I write this one? How can I simplify this one? This is plus, this is minus 2. So what do we get? So this is basically same, right? Omega plus omega square plus 4, right? So this is something similar to what do you call that 1 plus omega tau, right? That you can say, right? But this time my angle will change or what? Let's see. So what will my angle? Angle, right? Angle is basically 0 degree, right? Angle is basically 0 degree minus tan inverse. Okay, now this one will be a bit difficult due to this. Okay, sorry, not tan inverse. Due to this one, right? How much am I contributing? I'm contributing total 90 degrees, right? But due to this one, how much am I contributing? Okay, so I'm at the which axis? So tell me, what is this? Is this tan inverse simply omega by 2? Is this one? No, right? This is not this one. Why? Because like tan inverse omega by 2, right? But this is minus 2 here. So in which quadrant I'm lying? I'm lying in this quadrant, right? Lying in this quadrant. What is this quadrant? This is the third quadrant, right? Third quadrant. My real part is negative and my imaginary part is, okay, sorry. Okay, imaginary part is positive, sorry. So I lie in this quadrant, not in third quadrant, sorry. In the second quadrant, right? In the second quadrant. Okay, my real part is negative. Okay, real part is negative and my imaginary part is positive. So I lie in the second quadrant basically. Right, I lie in the second quadrant. So if I'm lying in the second quadrant, what does that mean? That means that what will my angle calculation be? It will be 180 minus theta, right? 180 minus theta. I hope you remember, right? I already explained it crystal clear very earlier. Okay, so I'm not going to further explain it further here. So it will be 180 minus theta. So 180 minus theta, which is tan inverse omega by 2 itself. Okay, so what is this? This is basically minus 270 plus tan inverse omega by 2, or you can say I'm adding 360, 90 plus tan inverse omega by 2. So how will my angle calculations look like? So this time, right, if my omega is 0, I'm starting with 90 degrees. So omega is 0, I'm starting with 90 degrees. And if my omega is infinity, right, so I will go to 180, right? I'll go to 180. I just simply added 360 degrees. So I'll just simply go to 180. Omega is infinity. What about the magnitude? So here, right, if it is omega 0, then this goes to infinity, right? This goes to infinity. And if if omega is infinity itself, then this magnitude will go to 0, right? Okay, let me draw this with different colors as this will be difficult. Magnitude will go to 0 basically. Okay, so like how will the plot look like, right? How will the plot look like? So like it will start somewhere from here, right? It will start somewhere from 90 degrees, somewhere along these lines, then it will go something like this. Okay, because it is ending at minus 180 or 180, whatever you want to say, right? So we start somewhere like this. Okay, I'm not drawing it perfectly, just hold on a second. Okay, and this will end at here, right? Or like to better draw it more perfectly, right, this will be something like this. this is omega equals to 0, and this is omega equals to infinity, right? So it is something like this one. And like, is this present over here? Like, which one is this similar to? Okay, can you, like, as I told you, right, can you predict the type of this one? What is the type of this one? The type of this one is type 3, right? Type of this one is type 3, right? So like, it is basically 270 degrees plus 90 is 270 degrees. And what is the order of this one? Order, right? If it is ending at 180, what can you say about the order? Order will be basically like, there will be some zero also, there can be some pole also, right? So what you can say is, like, if I try to write some equivalent minimum phase system of this one, what will be the equivalent minimum phase system? So let me first write it. So type is S cube only. Okay, type is S cube only, and at the end, where is it finishing? It is finishing at here. So what I can say is, I have a 0, right? I have a 0. Okay. So if you draw the polar plot of this one, right, this will be same as this one. Okay, polar plot of this one will be same as this one. I was trying to explain it in that summary example, but that I can't find right now. But if you draw the polar plot of this one, okay, the shape will be almost similar to this one. It will start at minus 270, or you can say at plus 90, right? Then what will happen? Slowly the angle will get added. Here also the angle is getting added, right? Angle is getting added, right? So the angle will get added, and it will go to 180 itself, right? So that is the issue, right? So for a minimum phase system, for a minimum phase system, that like minimum phase system and non-minimum phase system, the polar plots can be same, right? They can't be unique. Okay, so basically polar plot representation will not be an unique representation, because for like minimum phase system, non-minimum phase system, but it will be unique for a non-minimum for a minimum phase system. Okay, that you have to understand, that will be unique minimum phase system, right? It will be unique if my system is minimum phase system. Okay, so for some shape also, like, what you can say is, if my type is very high, right, type is very high, then also it can't be unique. Okay, then also, yeah, I would think about it. So like, you, for minimum phase system it will be unique. For non-minimum phase system, again, right, we can have parallel of those, right? Here, as you can see, the shape will be similar here, right? So they can be similar. You try to plot this polar plot, they will be similar. Okay, so we may obtain same polar plot for different OLTF. Okay, for different OLTF also we may obtain same polar plot also, like, and like for minimum phase system and like limited to type 3. Okay, after type 3 it may repeat, because there is some cycle, right? There is some cycle of 360. Okay, like again, right, we'll get some plus 90 over there. Okay, so after type 3 it may repeat, right? So like, it will be unique if my system is minimum phase system and limited to type 3. If my system is type 3, type 0, type 1, type 2, type 3 system, all those system will be unique. After that, right, after that it may repeat, the pattern may repeat, the representation may repeat, right? Here, right, the plot may repeat. So we won't be able to identify what was the transfer function, what was the transfer function of this one. So it is not easier for us to identify the transfer function of this one. Okay, that, I hope you got it. Okay, so we may obtain the same polar plot for different voltage. So this was the basically overall crux of this lecture, right? So what did we do in this lecture? Basically we solved few questions. That is okay, right? That is okay. Then I told you, like, how are my polar plots, but from transfer function I can easily go to the polar plot, but from polar plot I won't be able to easily go to transfer function. It is difficult, right? Just by seeing the polar plot I won't be able to say exactly this is my transfer function, because this polar plot can represent many transfer functions, right? Many. Okay, just not one. Okay, hence this polar plot is not a unique representation of my OLTF. Okay, of my OLTF. So that is one issue. Just by seeing the polar plot I won't be able to say that this is my transfer function, right, or my OLTF, not my transfer function, sorry, my OLTF, right? But from OLTF I can easily go to polar plot. That is not an issue. So that is what basically I tried to do in this last question, right? Okay, so yeah, that's why I wrote this key point, that my polar plot is not a unique representation for the same polar plot I can recover many OLTFs, right? Same, like many OLTFs. So I won't be able to tell whether this one was the OLTF of the system or this one was the OLTF of the system, right? It is difficult. Okay, that's why we don't generally recover transfer function, or we don't generally recover OLTF from polar plot. We go the other way. We know the OLTF, we plot the polar plot, not the other way around, that we know the polar plot, we try to recover the OLTF. That we don't do. Okay, so yeah, that is the end of this lecture. Basically we did few questions and we understood few concepts, right? And in the next lecture we'll understand about the relative stability parameters and about the stability of OLTF, right? About the, not the stability of OLTF, about the stability of my system. How can I find the stability of my system with the help of OLTF itself? Okay, it is very important. So yeah, let's we'll see you in the next lecture. Thank you for watching.